Hello, in this video I want to look at simplifying trigonometric expressions, and this is the precursor to verifying trigonometric identities. And really the difference is in simplifying trigonometric expressions, you're given something that you can either add or subtract or divide, but there's no equal sign per se. You don't know what the other side of the statement is. And so you're just, basically doing arithmetic operations or using some of your basic trig identities to convert things and kind of get what you think is another way of expressing that same expression that they gave you at the beginning. So actually, let me just kind of give you something to think about here in terms of, let's say, numbers. If I said a half plus a third, there's no equal sign there. That's an expression. So if I wanted to do something with it, I could say, well, I'm going to multiply by 3 over 3 here to the half, and the 1/3 I'm going to multiply by 2 over 2. So now I have 3/6 plus 2/6, and I get 5/6. So that's simplifying to an expression. If instead I had said, hey, a half plus a third equals 5/6, that's more of an equation, and maybe I could have said it something like this. See, now that's an equation, I can solve for it. All right, so an expression just doesn't have the equation part of it, the equal sign. We're actually solving for it. All right, so let's take a look at simplifying some trigonometric expressions. A lot of times what you'll be given are these kind of directions, something like write the expression in terms of sine and cosine, and then simplify so that there's no quotients that appear in the final expression, so you don't have something in the denominator, if it's possible, that kind of thing. Now, I am going to mention that these are the trigonometric identities you should absolutely know. You should really commit these to memory. And when I say commit to memory, I really mean I could shake you up in the middle of the night and say, okay, what's secant of an angle? And you go, oh, it's a 1 over cosine of that angle. Like, there's really no thought. You don't have to work for it. It's there. And you have to have that embedded in you so deeply. Why? Because when you're asked to verify things that are a little bit more complicated, if your recognition isn't there, I'm not even sure you can get through the problem. So you have to be able to recognize these things, and it's not a lot of things. You're looking at very, very little here, all in one page, and large writing. So here's some tactics to keep in mind when you're going through this. Some suggestions. You want to start, well, in this case I'm almost looking at it as if it's an identity. It's not, but you want to try using basic identities, using sine and cosine, when you can change something into sine and cosine. So by that I mean, if you're given cosecant, you want to express it as 1 over sine, so you want to make it simpler. You want to go ahead and try multiplying or factoring anything that you can. So this is going to be for identities, but basically this is the precursor to identities, so I'm just showing you that that's what they suggest in general for you to try to do. All right, so let's try one of them so you can see what I'm talking about. So I'm given cotangent of an angle divided by cosecant of an angle. What do I do? Well, I'm going to already start to express these in terms of sine and cosine. Now remember, you should already know cotangent is cosine over sine, right, of the angle. And now I'm going to make a really big line so that you know that's this right here, this dividing line. And cosecant is 1 over sine of the angle, okay? Now, just as if I had, like, two numbers, if I had a half divided by, 3/7, what would you do? You'd flip and multiply and say a half times 7/3 and then multiply across. That's what we're going to do here. So I'm going to have cosine of the angle over sine of the angle, right? Times, now I'm going to flip this and I have sine over 1, sine of the angle over 1. Now, of course, when I multiply across, what I can do is say, whoa, well, this sine x over sine x is really 1. So it's the multiplicative identity. 1 times cosine is just what? Cosine. So it's essentially, this simplifies to cosine x, okay? All right, let's try another one. I think I just lost my page. All right. So on this one, what I want to try to do is go ahead and do the operation of distributing. So I'm going to say cosine squared of the angle times, understood, secant squared of the angle. So if you need to, you can put a dot or parentheses, but it's understood these are being multiplied. Then minus, right, so I'm going to multiply that times that, and then here, cosine squared of the angle times 1 is just cosine squared of the angle. Okay? Now, let me simplify this a little, especially with the secant squared, right? I can say secant is 1 over cosine. So this is what I mean by you have to be able to recognize this, or else you won't know what to do next. Okay, so this is 1 over cosine squared of the angle. And now, when I multiply across, I'd have cosine squared over cosine squared, right? These cancel out. Well, they can't, you know, basically it's multiplicative identity. One divides into the other, and you get 1 minus cosine squared, right? And then here again, you need that recognition. Sine squared plus cosine squared of an angle is 1, but you really should know the rearrangements. So if I subtract sine squared from both sides, I'll get cosine squared equals 1 minus sine squared. If I subtract cosine squared from both sides, I'll get sine squared equals 1 minus cosine squared. So here, this is what? Sine squared of the angle. Okay? So all of this simplifies to sine squared of the angle. Okay? And let's take a look here. Here I have cosecant squared of an angle minus 1, and I'm like, So I'm already going to go ahead and change that into sine, right? So 1 over sine squared x minus 1. And now it's begging me to basically go ahead and subtract. So to subtract, because I have a denominator, I have fractions, I got to get this in the same denominator. So essentially what I'm going to do is this. I'm going to multiply by sine squared x over sine squared x. Again, you don't have to write all this down. I'm doing this for your benefit so you see it. So I have 1 over sine squared x minus sine squared x over sine squared x. Now I have the same denominator and I can subtract the numerator. Now I don't want to go canceling out because this isn't the multiplicative identity here, right? That'd be like if I said 1 plus 3 divided by 3. I can't just go across and say 1, right? Because this is really 4 divided by 3, which is 1 1/3. So be careful with that, or if I had minus, doesn't matter. All right, so now I recognize that 1 minus sine squared is cosine squared, right? Because I really know what I call my toolbox here. I really know these. I really know all of these. And now cosine squared over sine squared is cotangent squared, right? All right, so basically all of that simplifies to cotangent squared. Okay? All right, and one more. So I'm, again, trying to simplify this. And I just want to remind you that sine of a negative angle is the negative of the sine of the angle. Cosine of a negative angle is just the cosine of the angle. So, let me write this as this actually is. This is like sine of the negative angle, right? But this whole thing is what? Squared. So technically, regardless of what this ends up being squared, which is positive. But I want to use the identities so you can see them. And then this is, let me go ahead and change this into sine over cosine squared, right? And then plus, here we're going to have cosine of the negative angle squared, right? Now, we know that the sine of the negative of the angle is the negative of the sine of the angle, right? So that's here. Sine of the negative angle is the negative of the sine of the angle. So now I just have that. If you want to do that, you can. Okay. And then here, this would also be here negative sine of the angle. Now the cosine of the negative angle is just, so cosine of the negative of the angle is just cosine of the angle. So I'd say cosine of theta here. And now here, this is going to be just cosine of the angle, right? Applying that identity. All right, now it kind of doesn't matter when I multiply a negative. So this is really negative sine theta, right? Times negative sine theta, all right, because it's squared. And then this is, again, negative sine theta times negative sine theta all over cosine theta, right? And this is cosine squared theta. I can just write that now because that's positive, so you can see that. All right, but a negative times a negative is positive, so you're going to have sine squared theta plus, and here you have sine squared theta over cosine squared theta plus cosine squared theta. Now let me just rearrange this a little, or let me say sine squared theta plus cosine squared theta plus now sine squared theta over cosine squared theta. Right, so I basically just move this over. And let me get some more paper. But I know sine squared plus cosine squared is 1, so this is all now going to become 1. So I now have 1 plus, and then I have sine squared over cosine squared. Right. And so now I'm getting closer. It's a lot simpler. I'm trying to add these two things. I need to get a common denominator, so I'm going to multiply here by cosine squared theta over cosine squared theta, right? So now I have cosine squared theta plus sine squared theta all over cosine squared theta. I know that this is 1 over cosine squared theta, and that's secant squared theta. See, so it all did get really a lot easier. So you started out with all that and simplified it down to this. All right, thanks so much for listening.